Before I go into, well, I hope everybody has the software open. If you don't, let me know. Or if you have problems opening up the software, let me know. I also sent to you a link to the workshop materials, which should have, it's a folder that has exactly this. If you can't find something, let me know. We can always send it directly to you, but you should be able to access everything here. And if you go into Monday, we have, well, you have a PDF with a presentation that I went over today. Then you have this PDF called Constructing a Simple Model and View. No, for Wednesday, we don't have a folder for Wednesday, but we have these NMR exercise files, which is going to be related to that Wednesday part. I know it's called NMR exercise, but it's really more, there's going to be NMR and there's going to be formation testing. But Monday is what we're going to look into. And there's some things that are going to go over many days, so that's also why we have this outside. That's okay. So on Monday, we have constructing a simple model and view. And it has everything we're going to do in the next hour and 20, roughly. I'm going to go slowly, and you can reproduce it by looking at the video again and by just looking at this PDF. That should be enough. If you have more questions, of course, let me know. You can let me know here or let me know later through email. Okay, so this is what the software actually looks like. And like we were looking at in the presentation, you have these three main panels. You have the data tree in the left, you have the 3D view here, and you have the data panel down here. You have the project you can load, you can save, you can load specific wells. There's other things you can do. You can have project notes if you want to type something specific to the project. You have access to some multi-well options. You have access to the settings, and the settings are becoming more and more important in recent years. Settings is just sets for the software that are saved in your computer. You can always share them with colleagues, and you can always pass them from one computer to another, even your own computer. And then lastly, we have help. Lately, the software is crashing less and less, but if the software does crash, there's always this log file. If you're going to send a bug report or an issue report, it tends to help to send us this file. It's just a text file with everything that UTEP Wells has done. In this case, it's just opening. There's no errors, but if it crashes, likely there's some error here. So that can be useful if you're going to send us a report. And you also, help is actually pretty helpful in this case, because you have access to the application data folder. So it tells you where the data is being saved, where the folder is. Any simulation you run is going to be running, there's supporting files always that are being saved here. I think it's less and less the case, but in early days of UTEP Wells, people were doing their own analysis to the simulation, and some people, you may want to have access to it. This is how you would access it. Then this is just quick access to load and save the project. And then these are the two main types of data that we have in UTEP Wells. We have wells and we have surfaces. We're not going to work with surfaces. Wells is really the main type of data that we have. And if you click in this one, add well, you should be able to, you have added a well that you can see here in the data tree, and you will see this well interpreter should open immediately or without doing anything. It's not immediate. A word of warning: the first time you open UTEP Wells and the first time you open a well interpreter is going to be a little slower than the following times. This is just how the software is set up. So don't think that because the first time you opened it took a while, the software is that slow. The following times it should be this quick. Okay. So this is the well interpreter. This is the well, and now it has no logs, no Sonic, no NMR data, but it's here. The first thing that I'm going to do is I'm going to rename this well. If you right click on it, you can see multiple options. If you double click on it, it just brings up the well interpreter. If you click once, just select it. So left click, and then you can also well interpreter. You can have another well interpreter. Display settings if you were going to plot in here, and then properties is the one that I care about right now. So properties, and it tells you what is the well name, the API number, if you're going to use it, the well datum, if you're going to use it, including east and north. It's not just the elevation, and the current values. So in this case, I'm just going to call it simple model and say OK, and now it changed here. Now it has a different name. By the way, you can always duplicate a well, which is very useful. In some cases, you set up a well, and then you want to test different things like different invasion profiles or different resistivity values or different water resistivities, different whatever difference you may have. Something you can do is just set up everything that is going to be common to both tests, then duplicate, and then modify in one and see how that affects the well. So duplicating a well can be very useful, and this is how you do it. Just as a side note, I'm going to be making a lot of side notes because, well, the introduction. So anything that I think is important, I'm going to point it out. If you have questions, just go ahead in the chat or anywhere. So this is the well interpreter. We have it. It's working okay. Now the first thing we want to do is we want to load some data. So you can do it either going file and then load logs from file, or you can just go directly to the folder that is being opened and just say load logs from file. And I have it in the Monday folder. I'm just going to copy this. And then here in files being imported, I have to click again in the folder that is being opened. And I can just go to the Monday folder. And then I select the sample LAS file. This is the one that we're going to be working with, sample LAS. And again, the way I did it was I selected open, and I made sure I went to the Monday folder, and then I got it here. And here you're going to see all the logs that are being imported. You're going to see the units. You could change the units here, and you have the description, which also you could change it here to whatever you wanted. You also have you can choose which ones to import and which ones not to import. This is just with LAS. So in most cases, you import all of them, and you decide which one is the independent variable, the depth, the measured depth. This is always measured depth. And in case you don't want to import the whole thing, I know that in some cases you're only interested in doing modeling in a small section, so you can just import that part so that you have less noise around you. And once you're happy with all the things that you've done here, you can just say import. By the way, you can remove a file if you don't want to see it. And you can also view the file header, just for simplicity. All right, so you just hit import, and you're going to see that a few things happen here. The first thing is that the interval that we're seeing is different from the original interval, and that's because this is the interval of data that we have for that well. Well, for that LAS. So the first time you import an LAS is going to focus on that area, and it's going to change the units. It was in meters, now it's in feet. It's going to change the units to whichever units are preferred for that LAS, just to make it a little easier for you. Then, now that we have added this, we're going to start playing with whatever you're seeing here. So in the very first track, you always have measured depth, but you can modify that. And the second one, you have boundaries. Here you have the main controls. In top of the tracks, you have the first one is called the track editor. And if you click on it, opens this window. Alternatively, you can access that window just by double clicking in any track, and it opens it in the track that you double click. So you can see that now it's in track 2, now it's in track 1. And by default, it's going to show some shadow here, some tan on the track that you're editing. So now, right now, I just want to edit track number 2. You can add tracks here. You can also add them here by saying new track. And you have the reference track, by the way. The reference track is this track in the very right, that right now it's not showing anything. But, well, there's an issue here. It should be showing gamma ray. And you can just do that here. I'm going back to number 2. This not that important. So in track number 2, by default, it's always going to show the boundaries, or you will use this plot a lot, the plot of the boundaries, but we're going to add another plot. Here where it says track number 2 plots, you have a few icons here, and those are the types of plots that you can add. In most cases, you're going to focus just in the first 3. The other ones are going to be useful too, but the first 3 are really the ones that are used the most. The first one is the one that is used the most. It's just a log, so just a line. So it's asking us to add gamma ray. So I'm going to keep the boundaries, and then I'm going to add gamma ray. There's 2 ways I can do this. I can do it either using the LAS core, which gives you the option of explicitly selecting the log set that you're using, which in most cases just translates to the file that it came from, and then the curve, which gives you all the options that are from that curve. So I can just say gamma ray, and it shows here. It's red by default. I can change this to whichever color, and let's say it's green. And now it looks a little better. Notice that you have always the plots, and then you can select. You're always going to have at most 1 being edited. In the left, you always have the source. So in this case, the source is type, log set, curve. And then in the right, you have display options. So you can have the units. In this case, it's not interesting because it's just API. But if you had, for example, resistivity, you can see it in ohm meters, or you could see it as conductivity, or you could see it in different units. Then the limits, you can modify them here. You can just switch, or you can, let's say you're interested in, I mean, this wouldn't make that much sense, but if you were interested in this section, you could do that. And the wrap is going to wrap the plot around them. And you can always reset to the curves, to limits that are going to show the entire curve. The style is pretty obvious. The width also pretty obvious. Markers are going to be more. They're not very useful in this case. They're useful with core data. So now we've done the first track. Now we have gamma ray. And then I was saying that there's 2 ways we can do that. We can do that explicitly with the LAS, or we can use the mnemonic group. And what the mnemonic group does is you just select which mnemonic group here. Well, there's a certain type, it's going to be mnemonic group, and then group, you select which group. So I'm selecting gamma ray. And what that is doing is it's looking in all the files that I have available for 1 mnemonic for gamma ray. And the way it searches for them is using this mnemonic groups interface. And the way I access that is whenever you select in type mnemonic, you are going to get this extra window, and not window, button that says edit mnemonic groups. And you're going to see this access in many places because mnemonics are used everywhere, or they can be used in many places. So whenever you can use mnemonic, you can access the database of mnemonics. And it just gives you here the groups, the different mnemonic groups that we have predefined. Gamma ray is just name gamma ray. And then the type, it can be LAS or simulated or any. Those are the options that we have right now. Then the preferred display unit, in some cases you may have a different one. And then the curves that are being included. We have some by default, but they can be more. So that's it for gamma ray. You can have more. mnemonics for sure. Not only the ones we have here, you can have more. And we're going to do that in a little bit. So now it's also asking us to add another track. I'm going to add another track, and in this track 3 is telling us that we should have all boundaries. So I'm keeping all boundaries, and we should also have neutron porosity. So I'm going to add another one, and I'm going to do mnemonic group, and I don't have oh, I do have neutron porosity, and I think you do not have it. So I'm going to pretend I don't have it. So I'm going to remove this. Or you do have neutron porosity, but you do not have CN. Yeah, I think that's the case. So you have the curves, but by default, you only have some, not CN. So if I add it here and say LAS, not LAS, if I say mnemonic, neutron porosity, but I don't have any of the curves. If you see the definition that I have, these are the ones I have, but I know it's CN. And there's many ways you can do that. You can see here, this is the curve that we're looking at. Neutron porosity, CN. Or you can do it just with the LAS and then looking at which one you're going to use. So I'm just going to say neutron porosity. I'm going to add CN here. And you just type it in the last row and it should be included. Notice there's a ranking. So if in that well I have a curve named N phi and one CN is going to use N phi first. It's going to use N phi. If it doesn't find this one, it's going to go one by one until it finds one. Or if it doesn't find any, it's going to show something like this. Now, after I add it, I need to select something else and then select neutron porosity so that it finds it. And now it says, okay, curve CN, neutron porosity, fine. I did find it, so it shows it here. Let's shift the limits just so that it makes a little more sense. And I'm going to leave it as 0.4 to 0, but you can modify that to whatever you want. So now we have neutron porosity and we have gamma ray. Now we're going to explore a little more the data in this case. I'm going to add resistivity. So first I'm going to add another track. I'm going to add the boundaries and I'm going to keep the boundaries there. And then I'm going to add three resistivities. I'm always going to do it using the mnemonic group. And we have a shallow resistivity. You have to, here in the mnemonics group, you have to make sure that, again, the shallow resistivity includes MOR1. So in this case, you just have to make sure that it's included here. And then in the deep resistivity, so you're going to have shallow resistivity where you're going to add MOR1, and then deep resistivity is going to be MOR9. Notice that the O is actually a 0. In case you don't find it, that's got to be a 0. And then I'm going to add another mnemonic, and you see that I added by just clicking in this plus sign at the bottom of the mnemonic groups table. And now it's called just mnemonic 1, just that's the default name, but I need it to be medium resistivity. I just give it a name up here. I want it to be LAS. I'm just going to leave default unit as the display unit as default. And what that means is that it's going to take whatever unit is in this unit system. There's it's called units of measure. You just have the default value for all these different units that you may be displaying. And I access that here in this icon down here. You can also, it's the same one as over here in the main window. And I think you have to access it through the through these icons. I don't think we have any menu access, but that's okay. So that's what it means. Right now in resistivity or conductivity, we have ohm meters. These are the options. So it's going to show, when I say default, it's going to show in just whatever that is. And I have to give it a name. So it's for medium, I'm just going to say it's MOR3. So those are the 3 resistivities that we have. And I say, okay. Now that the mnemonics are ready, and remember, so I had shallow resistivity with MOR1, deep resistivity MOR9, and medium resistivity with MOR3. I can add shallow resistivity, then I'm going to add also medium resistivity and deep resistivity. And now I have all curves here. Of course, they don't look very good. First thing, let's make it logarithmic so that it looks a little better. And then you can wrap if you prefer to. Some people prefer to wrap. Some people prefer to just add some decades. So I'm just going to make 4 decades. I'm going to do both. I'm going to add 4 decades and I'm going to allow them to wrap all 3. And you see the shallow resistivities, the shallow resistivity does not wrap. Only the medium and deep over here. And that's okay. Any questions so far? This is just as simple as it gets to plot. So we plotted the gamma ray, neutron porosity, and resistivity. Something else that we can do in the top, you see the track, the options to different tracks, the add, delete. You can hide them. In some cases, it's convenient to hide them. And you can give them a title. I'm just going to give this resistivity title instead of just the number. Just makes it easier. And the second one, it's gamma ray. And the third one is neutron porosity. So I'm just going to say N5, even though it's not N5. It makes it easier and makes it easier to navigate around here. Okay, so this is how you would plot a log, as easy as it gets. Now, something else we're going to do is we're going to work with the template. And we're going to get into the options that we have here. First, everything you see here, we call, or the set of plots that you have, including the settings for that plot, meaning the color and so on, the limits, everything, we call that a template. And you're always going to be working in by default, you're working the default template. And you can turn anything you see into a new template. So what I have right now, I'm going to turn it into a new template. And to do that, you have 2 drop-down menus. One that allows you to select the template you're viewing. And the second one, whether you want to make a new template, this is going to make a new template with whatever you're looking at right now, or a new clean template, which means just a new empty template. So I'm going to say new template. And it shows exactly the same thing, only instead of showing this as default, is showing this as template 2. And then the third button that you have here, the one with the 3 dots, shows you this menu, which has the templates that I've used before, and also template 1, template 2. Template 2 is the one I was having right now. You can rename it here. So I can rename it workshop, for example. And then here it's going to show us workshop. Now, whenever you modify anything in the template, you can, or whatever template you have, you can always save it in your user settings. It will permanently save or update your template in the user settings. Your user settings are in your computer. So if you save it here, then you close the project and open a different project, and you want to look at this workshop template, you can do that. It can be very convenient. And then you can, so if I do that, if I save it, it's just going to make sure it's saved. And then it's going to show this as a checkbox. You cannot click in this checkbox. It's just an indicator. It just means that it has been saved. And you can revert to the last version. That's going to make more sense. For example, well, let me close this. If I move things around here, this is not making a lot of sense, but let's say, notice I can move, by the way, the curves here. I can just click in any legend and move it around. If I left click also, I don't only move it, but I duplicate it. So this can be useful in some cases. So I'm just messing everything up. Is not looking good anymore. But that doesn't matter. I can go back to what I saved. I can just click here and it's going to go back to what I had saved. Of course, in most cases, you're not going to do things that don't make sense. You're going to be playing with your template, doing things that actually make sense. And then if you want to go back to your baseline template, you just go in here, checkbox, good, you're done. You can add more templates, and this is where you would work with those templates. It's just to make it as user-friendly as possible. Okay. So now you saw that you can move plots. You saw how to work with the templates. Here you have some options. You can we have some standard views. You can 1 to 100. So any inch here represents 100 inches, and so on. Any of those values. People have some preferred scale so that you can select in here. Here you have, well, the second option here, the track display settings, is just for style that you may want to see things here. So for example, if I select expanded here, it shows everything as a little different. You can change the font. You can change depending on your presentation. You may want to change that. In this version, it's saved in the project, but in the newer versions, it's going to be saved in your user settings, so you don't have to redo it every time. I know that for branding, some people have to use different colors. So if you're in a company that's blue and white, for example, you could use something like that. So I don't know, depending on your preferences, you may want to play with them. But it's just mostly cosmetic, but we know that sometimes cosmetic is important. You can change the cursor lines and you can also choose to highlight the track that is being edited or not, and show modeling limits, which we're going to talk about them a little bit, and highlight the layer where the palette is being edited. We're going to talk about the palette in a little bit, or tomorrow actually. Anyway, this is just for style. So now I'm in a very bright blue style. That's okay. Now I can zoom in, zoom out. Zoom in, just one click goes in. If I double click, it goes out to the modeling interval. These green lines that you have here, you can change the style, by the way, but these green lines just represent the modeling interval, which is an interval that is used by most, well, by all simulators. Anytime you're going to do a simulation, it's just going to be between those modeling intervals. And any calculation, you can choose to do it in the modeling interval. So it's basically anything where you're interested. In this case, for example, you might be interested in just modeling this part. That seems to be where the oil is. So you can move it here, and you can zoom in just into the section that you're more interested in modeling. If you double click, it always goes to modeling interval. So you can zoom out. You can scroll, by the way, with the wheel of your mouse if you have one. You can pan up and down just by selecting this. And speaking of intervals, here you have the reference track where you can right click on it and you can modify some of the limits. You have the reference track limits that by default are going to be the limits to the total data interval, whichever you have loaded, it's going to be here. You may want to change them to whatever you want to focus in that area. The viewing limits, which is exactly that, just what are you looking at? You can reset them to the whole view. and the modeling limits, which are probably the most important ones. So I'm just going to set them to the current view, which is, you can also set them explicitly. Let me actually set them explicitly so that it probably is more constant, or it's round numbers. So I'm doing it from 12,250 to 13,210, whichever number works. Oh, that one actually doesn't work. So let me set modeling limits to current view, and that should be okay. That's okay. This is fine. So I have a question. Is there a way to customize the scale here to any? So yeah, we had that comment, and during the workshop, we're gonna make a custom option. We don't have it in the version that you have, but yeah, for example, 1200. We're gonna add one that just custom, and you can add it, and we can probably put in the user settings so that if that's a recurrent scale that you use, it should appear in all your projects, not just in the one you do it. I'm just making note of this because a few people know that it already. Okay. So this is what we have. This is okay. Now, the next thing we're going to do is we're going to actually start working with boundaries and with the Earth model. So there's many ways to do that. The most straightforward way to do it is just here. You have create new petrophysical boundary or create new property boundary. My advice, just use petrophysical. So let's click here, and you can, your mouse is going to change a little, and whatever you click here is going to add boundaries. This, of course, a very rudimentary way of doing it. This you're hardly ever going to do this, but it's an option. You can also, if you add this, the difference between property boundaries and petrophysical boundaries is that before we had this distinction, we only had petrophysical boundaries, but there's some fluid simulations. The fluid flow simulation requires it's better to have higher resolution for the fluids than for the rocks, because fluids change more than the rocks. So we added another type of boundary, which we call property boundary, which probably should be called fluid boundary, but we call it property boundary. So across petrophysical boundaries, all properties can change, including physical properties. So porosity, density, resistivity, fluid density, everything can change across them. However, across property boundaries, not all can change, only the ones that are related to fluids. But we call them property boundaries for historical reasons. That's okay. All right. Now, like I said, you can modify these too, but my advice, just work with petrophysical. You can also delete them. You can, if you click on this X, you can just X them out. You can also click, drag and drop and delete everything in that interval. You can also move them, and this is going to be actually a little more useful. You can move them up or down. This is when you're refining your Earth model, you may want to be able to do these kind of movements. Just click and move to whatever you think it's a better position. And then the last two icons, the arrows back and forth, is just undo and redo. So you can see, and this is for everything in the Earth model. Right now I was just playing with the position for the boundaries, but it can also be a property, and we're going to work with that in just a minute. So this is how you would work with boundaries directly in the track display. But like I said before, in most cases, you're not going to be working with, you're not going to be making your boundaries directly here. In most cases, what you're going to do is you're going to either get those boundaries from someone else because they've been set already, or you're going to detect them from the logs that you have. And to do that, there's this detect boundaries module. To access it, you go into here, Earth model, and then detect boundaries. Or you click in this icon that looks like 3 white stripes with blue boundaries. Just click here and you get this. And this is where you're going to have the option to load boundaries from a file in case you got it from somebody else. The file just needs to be a text file with the numbers, just the measured depths. You can give it units. You can give it. You can load them also in true vertical depth, or you can load them in measured depth. This is just the file definition in case you don't remember. You can also just detect them, which is what we're going to do here. You can, well, these are the options. The modeling interval, it's just a different view of the modeling interval that we had in other places. You can keep existing boundaries or not, or only petrophysical, in case you want to modify just the fluid boundary. So I'm not going to keep any of them, and I'm going to use gamma ray to detect boundaries. So here are all the logs that you have are in this list. And here is a list of the logs that you're going to use to actually detect the boundaries. First, I'm going to do just gamma ray. There's 3 methods that we have: maximum variance, maximum second difference, or extreme value. And most cases, maximum variance is good. This is just an explanation of how it works. They're pretty straightforward. Maximum variance just calculates the maximum variance in a sliding window. The sliding window is defined by whatever you have here. In this case, it's just 1 foot, but it could be anything. And then just select which one have the maximum variance in those windows. So there's always a window associated to each measure depth, and the ones that have a maximum or a minimum get a boundary associated to them. And same thing with second difference or with extreme value. Let's just use maximum variance. And if you just click detect boundaries, you're going to get a weight bar, and then you're going to get probably too many. This doesn't look very good. So you can, depending on your data, you may need to play a little bit with this. I know that the noise threshold 0.1 is just too small. So I'm going to make it 10%. And 1 foot might be enough. Sometimes 3 feet is probably better. And now you can see that it's just using gamma ray. So it's just using this log to detect the boundaries. And you can see that it's making a lot more sense. There are some places where it might be missing a boundary, or some places where there might be issues. For example, here you can see that, let me zoom in here. You can see that the resistivity is probably showing another boundary, but not gamma ray. So in that case, sorry, neutron porosity is showing an extra boundary, but not gamma ray. So it might be real, it might be not real. You can either just add CN, so neutron porosity, and then detect the boundaries with both and see what you get. In my experience, this tends to be just too much. So I tend to use just one. If we do it just with CN, you can see what you get. I'm just going to do it with gamma ray, and you can see how I'm passing them from one side to the other. If you just select them, or you have this arrow to move them from one to the other. Then just detect boundaries. This might be okay. Maybe then I can make the noise threshold a little higher, so that there's probably still a little too many. Something like this seems okay. Seems okay to me, at least at first sight. When you start doing inversion, you're going to see that there's some places where you definitely need more. So in those cases, you just add or remove or move whatever you need. The icons that we were playing with are going to help you with that higher resolution. For now, this is good enough. So we just stay here and we say we have detected boundaries, and these boundaries are fine for what we need. Okay. So now that we have boundaries, we want to generate an Earth model from here. And we're just going to do as simple as possible of an Earth model, which means that we want to have properties that are related to what we see. And to do that, the zeroth order approach is just to use this populate properties submodule. And you can see all of these. We were in detect boundaries, and you can see that it's a tab within a larger module. And then right next to it is populate properties. All of these modules are the Earth model builder. They all help you exactly do that. Just build Earth models. In the newer versions, we're breaking them apart just because it's easier. But for historical reasons, they were all together. And in these cases, that all of them used to be applied simultaneously. So you would detect boundaries and populate properties and everything at the same time. But now we allow it to be separate. So it's a little easier to interact with them. Anyway, that's another side note. So now to populate properties, all you're doing is you're given a certain property. Let's say I'm going to focus in gamma ray. You can populate that equivalent Earth model property using that log. By default, you have only these options. You can add more properties by right-clicking on this table. And then for gamma ray, you have to go to nuclear. So you right-click and then you go to nuclear, and you just select gamma ray, and it should appear here. And once you have gamma ray, you can select it here. Well, it's only going to give you the option of using logs that have the same units as the property, which makes sense. So you're going to have only the option of gamma ray. So gamma ray is going to be used to populate gamma ray. Makes a lot of sense. And then I just say populate properties, and you're going to have a time window. It's done, and just to tell you that it's done. Mine is in the other screen, so you don't see it, but it's done. And now in this track, besides populating the gamma ray log, I can show the Earth model gamma ray. I'm going to make it a little thicker just to make it more clear, and I'm going to make the boundaries a little less thick just to make it more clear. So you can see where the blocky log, the Earth model, got values that are related to the log, to the field log. The way that this algorithm works is it checks every layer. If it finds a maximum, it takes that maximum. If it finds a minimum, it takes that minimum. If it doesn't find any maximum or minimum, it takes an average, like in this case. It's not perfect, of course, but it's a first order approach. It's a first approach. It's okay. We're going to make it better as we go further. So this is just for gamma ray. Now I'm going to do the same thing for all three. I'm also going to make all the layers a little thinner. If there's questions, of course, there's the chat, or you can interrupt me. I'm just going to make all the layers a little thinner just because it's easier to see everything with thinner layers. Boundaries 0.5. That looks okay. Now, I'm going to do the same, but not just for gamma ray. We're going to do it also for neutron porosity. So I also need to add it. It's also nuclear. And nuclear neutron porosity. Of course, neutron porosity is always depends on the source and depends on the matrix. So let's do AMBE limestone. That's okay. And I can populate it using CN. Oh, actually, just with 4C. Well, let's ignore neutron porosity. Let's not do that. Let's just do resistivity. That's actually more interesting. And for resistivity is going to be more interesting because we have 3 values. So, and we can see that there is separation between the 3 of them, which makes us think there's actually invasion. So we're going to have more than 1 radial zone. We're going to do 3 radial zones. I notice a couple of interesting things. First, Gamma ray doesn't have anything for zone 1 or zone 2. That's because it's considered a petrophysical property, which means that it's not going to change depending on the fluids, which makes sense. So this value that you have in the formation is going to be the same for all zones, really. So you just have one option. Now, for resistivity, you have 3. So in the first one, we're going to use MOR1, second one, MOR3, and the third one, MOR9. So it's the same values that we use for shallow, medium, and deep resistivity. And for the borehole, we don't add anything. In most modeling tools, the borehole resistivity doesn't matter. There are some that do, and in those cases, you would have to include the resistivity here. Notice that if you know the mud resistivity, instead of using a log, you can say, well, I know it's 20, for example, and you just type 20, and that works out okay. Now, because we have invasion here, we need to have some radius, at least a guess. For the borehole, we have the caliper, so we're going to use the caliper, but we need to turn it into the radius. So we're going to do that in a little bit. At first, I'm just going to do 0.2. It's in feet, so it's very small, but let's say 0.5, half a foot. We're going to refine these later. And then in zone 1, I'm just going to say that I'm going to guess that it's 1 foot, and in zone 2, 2 feet. And then I just say populate properties. And it's going to take a little while. It takes a little longer, but now it's done, at least in my computer. And now the next thing that I'm going to do is I'm going to show you that resistivity actually populated this here. I'm going to, well, no, I'm just going to do all here. So in properties, you can see resistivity. And you have to make sure that you choose parallel or homogeneous. And you're going to have 3 zones. You're going to have the mud, which is just constant at the value that I put in, 20. Then you have invaded 1, which actually follows the trend that we have for MOR1. Something that can make it easier is just make sure that the colors are the same. So in this case, it's red, or it looks red to me at least. And then this one red, so you can see where that matches. I'm gonna make it a little bit thicker. So you see the red matches red in most cases. And then I'm going to do invaded 2, which in this case you can see it's really off because there's a maximum that makes it really off. So you could let's play with it. So this one seems green. I know that green is difficult to see, so I'm gonna turn it into blue. Now it looks a little better. I'm gonna make this also blue. So now we see how those match. I'm gonna hide the boundaries just to make it a little more clear. And you have the boundaries in the neighboring track, so it's easy to see. And you see what happened here, that there's this maximum that is messing the entire interpretation, but that's okay. If you see that you get something like this that is wrong, you can always just modify it directly in the track just by moving it, sliding it here. And that's true for all Earth model properties, and it's true all the time, so be careful. And you can always undo, like I was saying, you can undo, you can redo, and leave it in the place where you want. Probably in this case, to be safer, you would need to add a boundary here to make sure that that maximum is isolated and it's used whenever it needs to be used. And then if I populate properties again, you're going to see that it's going to change and it's going to take that maximum into consideration. But well, now it's not even thinking it's a maximum. It might be just a resistivity horn. That's another problem. Anyway, looks okay. And lastly, I'm going to do the invaded, which is the MO or the resistivity, the formation zone, which I'm just going to use black because it's easier to spot. I'm going to do it for both of them. and it's not invaded too with this formation. And you can see a little more clearly the trend. The shallow, well, you see annulus effect in this case, which is okay. Okay, now besides this, you can also, there's another way to visualize the resistivity. This is good, but there's another possibility, which is to view it as a cross section, which is here in the tracks and plots that we have. We can have this add vertical cross section. You see at first all of them are next to each other, except at here there's a bar, then there's another bar. Those bars means that those plots are not compatible. So you cannot have a log next and in the same track as a vertical cross section. So it's the first one that is not compatible to the others. That's the vertical cross section. And what we're seeing here is we're imagining that the well is always in the left of the track at the center. The center of the well is the very left of the track. Then you have the, well, is whatever you have in radial limits here. So 0 means that it's the very left. Then you have the mud. Then you have the first invaded zone, second invaded zone, and the formation in this case. And we're plotting resistivity. You can plot any property. We're plotting resistivity, and that's okay because that's what we're interested in right now. To make it a little easier to view, you can change the scale from logarithmic from linear to logarithmic. You can change the color map. This is just for visuals. Some people prefer different colors. Parula is the default MATLAB, and that I think it's okay. The property limits, we see that it's from 0 to 10,000. We probably don't need the 10,000. We can make this 1,000. And you see that the contrast makes a little more sense. It's easier to see what's going on. And because it's logarithmic, maybe it makes more sense to go from 10 to 1,000. Maybe even 100 is enough. This looks a little better even. Now, when you have 10 and 100, there might be some values that are below 10. And what's going to do is it's anything below 10 is going to take the color at the very left, and anything above 100 is going to take the color at the very right. So that's why you see some yellow and some blue areas. Maybe this could be 5, and you see that might be better, even 1. Yeah, 1 you actually see more, see better. I don't think there's anything below 1, so that's okay. And there's some really high cases, which is okay because otherwise we lose the contrast. And then the radial scale is linear. You can make it logarithmic. This is going to be more useful in cases where you have run a simulation because you have a grid that near the borehole requires higher resolution. So you tend to have more zones closer to the well. You can choose to show the boundaries or not, the grid lines or not. That's a matter of taste and the presentation that you're going to make. Questions or comments? This is pretty straightforward. So, but we need to go through this part to be able to go to the more interesting layers because, well, you need to be able to do the foundations.
Joaquin, I have a question.
Uh-huh.
I wasn't watching when you got your track 5, and I can't figure out how to make that.
Oh, track 5?
Yeah, oh, yeah. How did you make that one?
Right. So it's easy. All you need to do is, let's say that you add another track.
Yeah.
And then you add this one, the add vertical cross section.
Okay.
And then you play with the parameters to make it look like the other one. And the parameters, they look like, let me actually get rid of 6 because I don't need it. So what I made is I made the scale logarithmic and play with the limits. That's the most important part to see the better contrast.
Okay, thanks.
And that's it. Okay, now Something else that we did is we just populate properties with a radius assuming a constant value. But we know that that's not the case because we know that there was a caliper read and there might be washouts or there might be buildup. So we're going to do that. However, we could select here caliper, but that would not be right because caliper is for the entire diameter. So I'm going to show you how to make some calculations. So here in logs, if you select logs here, notice we have the Earth model and then we have logs. So it's if you're going to modify the Earth model, you go here. If you're going to modify the logs, you go here. So we're going to modify a log and we go into custom log calculations, and you should get this. And then you can just click in the bottom part to make that custom calculation. You can do simple calculations, which allows you to do these operations, or you can make a custom calculation, which is the one that you're going to be using more likely. The output, I'm just going to call it RAD for radius. And here you're just defining what are the variables that you're using. You can add variables or you can remove them. In this case, we're only interested in the caliper. So I'm just going to use cal, and it tells you what is the unique name. The reason why we're doing that is because you may have multiple cals. And where you're making, or here you're going to write the function that is going to be used. You need to know which caliper you're using or which cal. Let's say you have 2 cals and you want the average, you would do that here. But in this case, we don't need the average. We just need to divide it by 2 to get the radius. And the output units, you can either type here. I know that it's in inches. The caliper was in inches, so I need the output also to be in inches. Or you can select it here. You have all the options here. Because there's way too many units, it's usually easier to just type it. So just type IN. And that's it. And then you just say calculate. And there's no feedback right away, but because this is really fast, so there's no time window. Waiting bar. So now that has been done, you can double check that it was actually done here. In the log sets, you're going to see that at the very end now we have that RAD. And by the way, it was saved in that one. Sorry, leave the other one. I closed it. Let me open it up. So logs, custom calculation. You can select in which log you want to save it. But right now we only have log set. Sorry, we only have one log set. So it's going to just save it in that one. Now that we have that, for the radius, we can use the radius, which makes a lot more sense than just making a guess. And now I can just populate properties. And you should see that now the borehole does not have a constant radius. It has, for example, in this area, it has some washouts. Makes it easier to see everything.